So there is actually one other way that we can solve a system of equations that I did not talk about, and that is using a matrix. So let's first take an example of a system of equations in three variables, and then we'll discuss what that means. So let's look at this system here where we have negative 5x plus 3y plus 4z is equal to 2. And then we have 3x minus y minus z is equal to 4. And lastly, x minus 6y minus 5z is equal to negative 4. All right, so we have our system, and so solving using a matrix, we can take this system of equations and we can rewrite this in matrix form by looking at the coefficients of all of the variables. So to do that, we're going to have to first create a matrix using a bracket and the coefficients. So I'm going from top left down, or I can go from top left across, and we'll look at the first equation first. The first equation, our coefficients are negative 5, 3, and 4. And then we have all of that is equal to 2, but we'll write that in a moment. Okay? Then the second equation, we have 3, negative 1, and negative 1. Okay? And then our last equation, we have 1, negative 6, and negative 5. And then we can close this off. And all of these are represented as x, y, and z variables. And these correspond to values on the opposite side of the equals sign of 2, 4, and negative 4. Okay, so this is how we would rewrite this system of equations as a matrix. Moving further than this, to actually begin solving, we're going to rewrite this matrix so it's a little bit easier to begin solving. And I'm going to rewrite it as negative 5, 3, 4. So this part of the matrix is going to be the same. 3, negative 1, negative 1, 1, negative 6, and negative 5. And then we can make a little bit of a line here, and then we're going to write our solutions. 2, 4, and negative 4. And then we're going to close our bracket. Okay, so what I want you to look at right now is this 3 by 3 block right here, this 3 by 3 area of the matrix, not the solutions, just the coefficients. There are row operations that we can make on each of these rows that will simplify this matrix down until all that we are left with is a value for x and a value for y and a value for z, in that order from row 1, row 2 to row 3. So the way that we're going to know that we're at a point where we can actually write x equals some number, y equals some number, z equals some number, is our matrix will look like this. And for the 3 by 3 matrix, we have 1 in the x column, 1 in the y column, and 1 in the z column, and then you'll have your line and then some values for your solutions. So this portion of the matrix right here is known as the identity matrix. And what it's saying is that you have a coefficient, so each of these correspond to x values, each of these correspond to y values in the middle row, each of these in the right row right column rather correspond to z coefficients. So here we have a coefficient on the x column of 1. Here we have a coefficient on the y column of 1, and here we have a coefficient on the z column of 1. So I know that whatever values are over here in our solutions area, x is going to be equal to that value, y is going to be equal to this middle value, and z will be equal to this bottom value. So what we're trying to do is get this matrix over here on the left to look like this, using row operations. So our row operations, we can multiply a row by a constant. We can move rows around. I can switch out row 1 with row 2 or row 1 with row 3. And I can also combine rows. So this is just like elimination, the way that we were solving previously using elimination. It's really no different. It's just a little bit simpler way of looking at things without the variables and just using the coefficients. So the first thing that I'm going to do here is to start making this matrix look like the identity matrix. I'm going to multiply row 1 by 3/5 and then add it to row 2. So first operation, I'm going to add 3/5 times row 1 to row 2. Okay? And that does not actually alter the first row. All I'm doing is altering the second row. It's because I'm taking a constant times the first row and combining it with the second row. And that is one of our possible row operations. So our first row is going to stay the same, -5, 3, 4. And then, of course, we have 2. And then our second row, so if I multiply -5 times 3/5, I'm just left with -3. And then if I add that to +3, that's going to give me my 0 here. And that was actually the reason why I multiplied it by 3/5 in the first place, is to eliminate that 3. And now we're just left with some other values in the rest of the rows. So here I'm going to have 4/5. And here I'll have 7/5. And this is a little bit messy right now, but it will be a bit cleaner in a moment. And here we'll have 26/5. And then our last row stays the same. So we have 1, -6, -5, and -4. Okay, so the next thing that I'm going to do is clean up this second row a little bit. I'm going to multiply that whole row by 5 to eliminate all of those messy denominators. So if I do that, I can write that here. So second operation, multiply 5 by row 2. Okay, and then I'm left with same in the top, -5, 3, 4, 2. And then I'm left with 0, 4, 7, and 26. And then 1, -6, -5, -4. Okay, so now it's a bit cleaner. So the next thing that I want to do is I want to eliminate this one in the bottom left-hand corner here. And the way I'm going to do that is I'm going to multiply row 1 by 1/5 to make this -5 into a -1, and then add it to row 3. So if I do that, I will have our third operation as add 1/5 times row 1 to row 3. Okay. And then I will be left with, move down a little bit. I will be left with the same thing in the first and second rows, -5, 3, 4, and 2, 0, 4, 7, and 26. And then our last row will now become 0. And then we're going to have some messy stuff again. We're going to have -27/5 and -21/5 and -18/5. Okay? All right. So we're moving along slowly but surely. And now the next thing that I'm going to do is I'm going to clean up, but also reduce a little bit the third row. So the third row, I can get rid of all the 5's in the denominator, but I can also recognize that all the numerators are divisible by 3. So, and they're all negative. So what I can do is I can actually reduce all of them by 3 and then eliminate the denominator and the negative sign. So to do that, I will multiply row 3 by -5/3. Okay, so if I do that, I'll be left with the same thing in the top 2 rows, -5, 3, 4, and 2, and 0, 4, 7, and 26. And then the last row will be left as 0, 9, 7, and 6. Okay. So now we're getting a little bit closer to our identity matrix here. I think, well, what's left to do now is I think the first thing I'm going to do is I'm going to swap row 2 with row 3. And you'll see in a moment why that is. Because then if I multiply 4/9 by row 2 and then subtract that from row 3, I'll eliminate that 9, or sorry, I'll eliminate the then 4, which is now in this bottom row down here. So let's do that.